Good morning, everybody. Today we're going to take a look at how fractions can be used to help with photography. Now, Miss Breen is a math teacher, but she is also a photographer, and I've been taking photos for a very, very long time. And one of the most important things that I have learned with photography is that fractions are important. So, whether it be concert photos that I have taken, or if it's been weddings that I have done, or even some traveling that I do on my free time, fractions has helped me become a better photographer. So, we're going to take a look at why fractions are important today in our lesson and how they're used to help with making prints for photography. Now, today in this world, most people keep their photos on their phone, or they use their computer to look at photos, or they use the TV, or maybe they have one of those digital picture frames. But every now and again, you might want to print your pictures. For example, Miss Breen has this little calendar here that she uses, and she has made prints of her pictures in a calendar. Or maybe you want to get an enlargement for your wall to hang up, okay? So when you're making your prints, you have to understand equivalent fractions so that you get every bit of your photo on the printed paper. Okay, so we're going to take a look at this. Miss Breed is just going to minimize her screen here and just kind of slide this over. I don't really need my picture all the time. All right, I'm going to pull up two photos that I have. Here's one, and here's the other one. I'm going to do two of them. It's coming. All right, so here we go. Miss Breen has two different pictures here. One is a picture of her family, and the other is a picture of her favorite beach. Now, each of these photos have a different length and width, and we're going to talk a little bit about what that means in photography. This photo here is a little bit longer than this one, and this photo is also not as tall. So if you look at the distance between the top and the bottom, this one is actually shorter. This is because this photo has what we like to call a 2:3 ratio. So that means 2 on the left, 2 here, and a 3 on the bottom. So if we were to look at this as like a fraction, you could imagine it being like 2/3. So when we were doing arrays and we were making an array and we were shading in the squares, this would be making it like a 2:3 array. This photo is a little different. This one has a 3:4, 3:4, 2:3, 3:4. So this one has one more on the left, so instead of 2, it's 3, and at the bottom, it's 4 instead of 3. So this has a different area if you think about it as an array, and we're going to take a look at that on some graph paper in a few minutes. All right, so here we're going to enlarge this photo. I'm going to take this one up nice and big, and I'm going to pull up the cropping tool. Now, this is where fractions really come into play when you're cropping photos. Now, a lot of you crop photos all the time, and you just come over here and you just kind of slide this over. I'm going to put it on custom, and you can just crop it however you want. So you might make like a weird crop. See how Miss Breen just kind of doing that and just, okay, I've cropped my kids out of the photo, and this is just Sean and his two girls and Ryan, who is Jillian's husband, okay? I don't want to do that though. I want my whole photo. So I want to make sure that I keep the original aspect ratio. And what that means is that every bit of the photo is going to stay as a 2:3 ratio. So when I print it and I get it on my wall, I'm not going to lose any of my picture. None of this is going to be cropped out. Now watch what happens if Miss Breen were to say make an 8:10. Miss Breen wants an 8:10. She has a frame, and it's an 8:10 frame, and I want this picture in the frame. And I go to the store and I tell the Walmart or Walgreens, give me an 8:10 of this photo. Watch what's going to happen. Oh, that's a problem, right? my 8 by 10 is not matching the length by width, which is the 3 or the 2 by 3 ratio, or it does not match a 2 by 3 if you're thinking about it as an equivalent fraction. It doesn't match. I'm losing all of this photo and all of this photo. Now, I can decide maybe I want to crop Hunter out and just keep Caitlin. I don't think Hunter's going to be too happy about that. Maybe I want to cut Caitlin out and just keep Hunter. I don't think Caitlin's going to be happy about that. And if I decide that I want them both in, I'm going to lose a quarter of their eye right there, okay? So this is not going to work. And that is because 8 by 10 is not equivalent to 2 by 3. They don't match. They're not the same. Okay, so that's just not going to work for me. So Miss Breen's going to set that back to the original. I'm going to keep that photo because I don't want to crop anybody out. Okay, all right, so let's get rid of that one. All right, so now Miss Breen is going to pull up the other photo. We're going to talk about how that one's different. I'm going to slide this one out of the way. I'm going to make this one nice and big. Okay, and I have the cropping tool up for this one. Now, this ratio is a little bit different. And so is the photo. There's a lot of empty space here. Unlike the picture of my kids where we were all together stacked on top of each other, now I have this photo that has some room that can be cropped. So let's say I want to put this in the frame instead. Watch what happens. I lose some of my photo, but not as much. Not as much. That is because this is a 3 and a 4, so it has a little bit more space. A 3 to 4 ratio is a little bit closer to a 8 by 10. Still not the same. I'm still going to lose some of my photo, but do you notice I can pick and choose and go, you know what? I can stand to live without that telephone, that light post. I can slide it over and look, I get all of the tiki hut here. I still get this nice beach photo. This would work, okay? This would work. Now, remember how we said that photo before, and again, I might be that this photo is a 2 by 3 ratio. So watch what Miss Breen's going to do. Instead of an 8 by 10, I'm going to do that same ratio as my family photo. Now, the length and the width have the same ratio. And check this out. I'm going to lose just a little bit of the sky here, which isn't so bad, right? I could still crop and keep out that light post, but now I have just created my photo of the same ratio as my family photo. All right, let's get that out of here. I don't want to save. Okay, here we go. So let's take a look at how this looks mathematically. All right, Miss Breen is going to make the camera nice and big. I'm going to slide it around, and we're going to use good old-fashioned graph paper. Okay, so how does this work? Well, in fractions, we have learned that in order to make an equivalent fraction, we must multiply the numerator and the denominator by 1 in the form of a fraction. And we've been doing a lot of practice with this lately. Okay, so for example, if Miss Breen multiplies the numerator and the denominator by 2, 2/3 is the same thing. 2/3 is the same thing as 4/6. Okay, 2 times 2 is 4, and 3 times 2 is 6. And we have looked at this by using arrays. Okay, so we've kind of had this discussion where if you look at a 2 by 3, okay, so here is a 2 out of 3, and by taking that fraction and looking at it like this, we now have 4 by 6. It's the same exact shape, but we have divided it into smaller pieces. Well, when we're working with photography and we're enlarging prints, we're actually doing the same thing, but we're growing in size. We're expanding the photo from a very little picture like this on my computer screen to a huge, large photo that I'm going to put on my wall. So watch how that works. Okay, so I'm going to come down here and I'm going to sketch a 2 by 3 array. 2 on one side, 3 on the other. This represents the original image of my family photo. Now, let's say I want to make that just a little bit larger. Let's say, just like my fraction 2/3, let's say I multiply that by two halves, I will get 4/6. Okay, so now I'm going to create a 4/6. 1, 2, 3, 4 by 6. 1, 2, 3, 4, 5, 6. Okay, so here is my 4/6 array. Now watch how cool this is. I'm going to change the color, and I am going to show you that inside of this picture we have 2/3 4 times. Watch this. Here you go. Here's a 2/3. Here's a 2/3. Here's a 2/3. And here's a 2/3. So what we did is we multiplied the length by 2 and the width by 2, and it increased it at the same rate. So the relationship between 4 and 6 is the same as the relationship between 2 and 3. They've both been multiplied by 2. Now in the fraction world, we're multiplying it by two halves, and we're making smaller little pieces that we're actually shading in the same amount of space. This, we're enlarging the photo at the same rate. Okay, so now I have a 4/6. This is your standard print when you go into Walmart and you get pictures printed to put on your wall, like little pictures to put in your locker. This is a 4/6. Okay, so now what happens if we go by 3? What if we want to enlarge it by 3? So now I have a 2/3, and I'm going to multiply the numerator and denominator by 3. Okay, very similar to what we do with fractions. Okay, and we would get 6/9. All right, so let's check it out. Let's test it out and see what happens. I am going to sketch a 6/9. 1, 2, 3, 4, 5, 6. I need a lot of space for this. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, here we go. Now, watch this. Here's a 2/3. Here's a 2/3. Here's a 2/3. 1, 2, 3. Look at that. So what we did is we just increased my original by 3. Now I have 3 of the originals embedded in there. And watch what happens with the top. Here's 1, 2, 3. There it is, 3, 9. So now we have an equivalent enlargement. We can keep going. We can keep going into infinity. However, prints cost a lot of money. So when you're trying to figure out what size photos you want for your wall, you need to keep that in mind as well. Okay, so here's a 6/9, okay? Which is very close to an 8/10. We're gonna do an 8/10 next. What happens if remember when I took my picture of my kids and I cropped it and I used I'll show you again real quick so we can just kind of see it. I used the 8/10, and look, I lost some of my photo. Here's why this happens, okay? So I'm gonna slide this back out so we can see our graph paper. Here's how and why this happens. All right, so Miss Breen's gonna get a blank piece here so we can see it nice and clean. All right, so here is a 2/3 or a 2/3 fraction. So let's look at it like we're looking at fractions. If I have 2/3 and Miss Breen says, is 2/3 equivalent to 8/10? Okay, is it equivalent? All right, so remember we have that math tool where we could actually create the tool. We could actually pull it out. Miss Breen will actually do that real quick because we have a minute, and I'll show you. So if you're using the free math apps tool, that tool is an exceptional tool for learning fractions. So I have it up here on my screen, and I'm just going to kind of slide it over so you guys can see it. All right, so we're trying to compare 2/3 and 8/10. So I'm going to pull this up. I'm going to minimize it so we can see both. All right, is a 2/3 equal to 8/10? All right, so I'm going to use my little fraction bar, and I'm going to make my thirds, and I'm going to make my tenths. Okay, I'm going to shade in, pick a color, 2/3, and I'm going to switch the color for my 8/10. 1, 2, 3, 4, 5, 6, 7, 8. Notice they are close, but they are not equivalent. They are not equivalent. So if I go back over to my little paper here and I do the math, I can see that if I want to skip count by 2's, I can multiply by 4, 2, 4, 6, 8. I will get 8, but what happens when I do that also to the denominator? Remember, it has to be the same. The numerator and denominator has to be the same because it's the same as a whole. And when you multiply something by a whole, you're not really changing it. We're just actually creating smaller pieces. So 3 times 4 is 12. It is not 10. Okay? So these two are not equivalent. Okay? Same thing happens when I enlarge my photo. When I enlarge my photo and I try to create an 8x10, I really need an 8x12. So when I go to the store and I ask my, print person, hey, can you make this picture for me, but I want it to be an 8x12, not an 8x10. So watch what happens when I shade in 8/12. Look at that. Now I have an equivalent fraction, and when I go to get pictures of my kids, they're not going to be disappointed when only half of them are in the photo. Okay, so again, this is another cool tool and how we can use equivalent fractions with our photography. Now today, you're going to have the opportunity to explore with some graph paper and some shapes and be able to enlarge and create equivalent ratios with some print sizes. So you'll get to see how this works. Sometimes you might have a photo that just you can't crop it and you have to keep it as it is, but a lot of times it's nice to maintain the same ratio as the original photo. And we're going to focus on 2x3 today. Now, I will tell you that the original beach photo, that original ratio of the beach photo, this is a 4x3 or 3x4. You can say either one, 3x4 or 4x3, is the same exact photos size that your phone is. So if you're taking pictures with your cell phone, you're working with a 3:4 ratio or a 4:3 ratio. If you're working with a digital camera, like a professional camera, a lot of Miss Breen's photos that she takes, these are 2x3. 2x3. Now I'm going to share one more photo with you before we go, and then we'll get some practice. Call it some practice time. All right, so here's this nice photo Miss Breen has of her kids and Mr. Sean at the beach watching the sunrise. This photo is a 16x24. 16x24. So I want you to think, is a 16x24 equivalent to a 2x3? So that's your thinking question. So before we get working, I want you to think, is my 16x24, is it equivalent to the original aspect ratio of a 2x3? If I were to enlarge it like I did with my pictures here, and I got to 16x24, would I be able to fit 2x3 little boxes in there to show that they are equivalent? All right, so think about that, and we will get into some practice problems and have some fun exploring today.